Hello, I'm Andrew, and I was working on doing time series analysis on influenza data, specifically supporting the CDC flu site challenge. And so the CDC flu site challenge, they've been doing it since 2013, and they're asking teams of researchers to forecast the influenza rate, and actually several targets. So there's the influenza rate, the start of the flu season, which is determined by a baseline that's established by the CDC, the peak intensity of the flu season, which is just like the highest percentage it'll reach that year, and the week in which it'll reach that peak intensity. And so looking at the mechanics of the actual challenge, this is the data that the CDC publishes weekly on the flu rate. Then they they publish data nationally and by 10 regions established by the Department of Health and Human Services and by state. And so they update this weekly, and this was the primary data set that I used to incorporate and train our time series analysis models. So for the implementation of my specific product, I created a harness that can just kind of train and test not just one specific univariate model, but just a wide range of univariate time series analysis models, because these are pretty simple models, and so it helps to kind of look all over the time periods and see okay, how would this model perform for the 2017 and 18 season, or how would this model have performed for the 2014 and 15 flu season. And so the CSV file is an example of an output, and that would be the score submission that you submit to the CDC challenge. And the way they do the scoring is in bins. So your model could return a point prediction, but you could have a level of confidence in your specific prediction, and you'd say, oh, I'm extremely confident that the flu rate will be 2.4% or something. But then you would for my models, I wrapped a normal distribution around it so that there's uncertainty in your prediction. And when there's a few steps to making your model. So you got to collect the data, then pre-process, train a model, and then output, generate plots, or do other error analysis. And so my model, or my harness, will handle all of that, and then the actual model that you can kind of plug in will run in this command line script that I created. And so that's just a sample usage of the command line script using a simple autoregressive model, and it generates a prediction for the 40th epi week of the 2018 year using training data from 2002 until 2018. And this is a sample plot generated of the same thing. This is a 1 week ahead prediction using a simple autoregressive model on the 2018 flu season. And so, I mean, you can see that it tracks decently, especially along the beginning and ending periods. I mean, obviously, the harder part to actually predict would be the middle part, where the fluctuations are greater and it can go down. But when you're looking at the end and the beginning and stuff, it's not obviously it'll track pretty well. And so the advantage of having a harness is that the flu seasons of 2009 and 2010 were just particularly intense. And so if you wanted to, you could immediately backtest any univariate model that you come up with on those crazier flu seasons and get results for that. And so, I guess in terms of future implementations, we would want to look at transitioning from univariate to multivariate models, because the primary data set that we're using right now is the flu data, which is published weekly. But if we want to incorporate multivariate models, we could look at the correlations between HHS regions and how they would impact like a national forecast. Or like if you look at geographic correlations between HHS regions, you could arrive at a better prediction for a specific HHS region. But when you start to consider those multivariate, when you start to increase the order of complexity of your models, it becomes obviously a lot harder to create like a clean scaffold for it that you can just immediately like click any option and like create output. So that would definitely be an order of complexity that we'd have to look into. And then as far as challenges I faced trying to implement this harness, where one of the challenges was data validation, because when we were using the primary CSV file, like not all the data is just there. Like data is missing. Data can be updated because of backfill. So like hospitals will regularly, like they'll publish a report, but then they'll send in additional data the following week, and then okay, now your model is has changed. So as the harness stands right now, it's not very robust, and that like small, like a typo or something could just break the harness and it just return an error. So we would want to improve data validation in that regard. And then date conversions. So the CDC uses epiweeks, which is defined as the first epiweek of the year starts ends on the first Saturday of January, as long as it falls at least 4 days into the month. So essentially the first epiweek of the year could start not on January 1st, but like December 29th or something. So you have to account for that, and when you're trying to convert between those dates and like the dates that like in pandas when they recognize those dates. So that's definitely something that I had to take into consideration. And then ideas for like future implementations and future iterations of this. We definitely want to work on increasing the data validation, and also like adding more error analysis of like these models, and more more ways to just quickly analyze and like generate analysis for our predictions. And that's my project.